Welcome back to ESA's Earth from Space program. Today the Copernicus Sentinel-2 mission takes us over the algal blooms swirling around the Pacific Ocean, just off the coast of Japan. Algal blooms refer to the rapid multiplying of phytoplankton, microscopic marine plants that drift on or near the surface of the sea. Excessive algal growth, or algal blooms, can become visible to the naked eye and collectively tint ocean waters, allowing us to detect these tiny organisms from space. Although algal blooms are a natural and essential part of life in the sea, human activity is also said to increase the number of annual blooms. Harmful algal blooms can be stimulated by environmental factors, such as warmer water temperatures and excessive nutrients. In the image pictured here, high concentrations of algae can be seen around 130 kilometers off of Hokkaido Island, the second largest island of Japan. This particular algal bloom measured more than 500 kilometers across and 200 kilometers wide, with the area pictured here showing just a small portion of the bloom, around 100 kilometers from north to south and around 110 kilometers from east to west. During the spring bloom season, nutrients such as nitrates and phosphates are more abundant in the surface waters. Without direct in situ measurements, it is difficult to distinguish the type of algae that covers the ocean here. Algae is then usually carried by winds and currents closer to the coast of Japan. It is in this part of the Pacific Ocean, near Hokkaido, where the colder or Yasho current converges from the north with the warmer Kuroshio current, which flows from the south. When two currents with different temperatures and densities collide, they often create eddies, swirls of water drifting along the edge of the two water masses. The phytoplankton growing atop the surface waters become concentrated along the boundaries of these eddies and trace out the motions of the water. Phytoplankton play an important role in the food chain, but they also have an impact on the globe and carbon cycle by absorbing carbon dioxide on a scale equivalent to that of terrestrial plants. Primary production is often used to describe the synthesis of organic material from carbon dioxide and water through photosynthesis. Even small variations in primary productivity can affect carbon dioxide concentrations, as well as influencing biodiversity and fisheries. As ocean surfaces warm in response to increasing atmospheric greenhouse gases, phytoplankton productivity will need to be monitored both consistently and systematically. Satellite data can be used to track the growth and spread of harmful algal blooms in order to alert and mitigate against the damaging effects for tourism and fishing industries. It has also proven fundamental in providing a global view of phytoplankton and their role in response to climate change.